Okay, I'm going to talk about running R in batch mode, and I will share my screen. This. And first I have logged into UPPMAX, Rackham, and Cosmos. And in each of those, I have made sure I have the exercises, and I would like to once more show how it is you get the exercises. So in the first introduction page, we will go down to this place here, and here I will copy this command here, which I use to download the tarball with the exercises. I'm doing that, and that gives me a tarball named exercises.tar.gset. And to uncompress the tarball, I use tar minus x v set f, and x is just for extracting it. V is verbose, which means it shows what it does all the time. I mean, you don't have to do that, but I like to see what is being unpacked. And then set is because this is a gzipped file. Gzip is a compression program that is more efficient than regular zip. And F is just that it tells it that it should unzip the following file, and that is the exercises. tar itself is a program that concatenates all the files together in an archive or something, I guess, and then you can afterwards zip it together. But let's extract it. And so let's see what is inside the exercises and R directory. And this is what we have here, and that is most of the exercises, most of the R scripts that we're going to use in this course. So let's return now to R in batch mode. So first question you may have is, what is a batch job and how do I write a batch script and submit a batch job? So the idea here is to give a short introduction to the SLURM scheduler, to show the structure of a batch script, and also give some examples you can try. And now it's important here to pay attention to these computer allocations, the project IDs, because we will need those in the batch script in order to tell the batch scheduler which allocation we will be running in. And there is one for Rackham, and that is actually not the correct one. It should be 1202 here. We need to fix this. This one should be 114. This one, on the other hand, is correct. Yeah, I will fix this, but it will be fixed in the exercises. Also, there is storage space for this project. This is the location on the Rackham. This is the location on UPPMAX. If you haven't already, then you need to create a directory for yourself to work in. But I believe you probably already did that in one of the previous sessions. On Cosmos, we have enough space in the home directory that we can work there, about 100 gigabyte. Rackham and UPPMAX each have about 25 gigabytes. So let's do an overview of the UPPMAX system. First, we have a terminal or ThinLink login, which the user uses to get to Rackham. And there they arrive on the login node. And with sbatch for batch jobs, or with interactive for interactive jobs, they can run jobs on the calculation nodes. And it is also possible to send jobs to Snowy. The thing is that Rackham does not have GPUs, but Snowy does. So from Rackham, you can send both batch jobs and start interactive jobs on Snowy's calculation nodes. Then also UPPMAX has Bianca, which is sensitive data and is a bit more advanced to log into and use because it's simply more secure. So you're going through a step more where you only get to a private cluster that you work instead of access to all of it. But that is for another course. There is a Bianca introduction that you can follow if you're interested. So the HPC2N system. There also you connect with either from the terminal, as I'm doing here, or you connect from a thin link session, as you also may do, many of you may do. And so then you get to UPPMAX, you get to the UPPMAX login node, and there you can submit either regular batch jobs or interactive jobs to the compute nodes. Compute nodes is what calculation nodes are called at UPPMAX. As for LUNARC, much of that is the same as for HPC2N. There is the Cosmos system that works the same way as UPPMAX, but then they also have a Cosmos Sense system for sensitive data. And there is also a secure connection there, just like for Bianca, more than for the regular one, even though that also has two-factor authentication. And it is set up much the same as Bianca in many ways, where you also get access to a private cluster within the cluster. Okay, so batch jobs. Yeah, when you are running something on the login node, you may end up using quite a lot of resources and making the login node very, very slow, so nothing can run on it. And that affects not just yourself, but also all the other users. And because of that, any longer resource-intensive or parallel job must be run through a batch script, or either as a regular batch script or as an interactive batch job. We will talk more about interactive work in a later session. This is the case on all the HPC systems. And the batch system used at UPPMAX, HPC2N and LUNARC, and most other HPC centers in Sweden and elsewhere is called SLURM. SLURM is an open source job scheduler, which provides three key functions. It keeps track of the available system resources. That is, it knows how many CPUs, how many GPUs, how much memory, and things like this. It enforces the local system resource usage and the job scheduling policies. So it makes sure that jobs get to run in the right order, and it manages a job queue, distributing the work across resources according to these policies. So in order to run a batch job, you need to create and submit a SLURM submit file. If you Google this, look online, then you find that these submit files also are called batch submit files, batch scripts, job scripts, and several other things. It's all the same. There are guides and more documentation. Here at the HPC2N's documentation info, and one's for UPPMAX and one for LUNARC. And you can go there to read much more about the batch systems. So what is the workflow when you want to use the batch system? Well, first you write a batch script. And inside this batch script, you need to load the modules that you will need for the job. This are any prerequisites and things like this. If you are using any own installed packages, either make sure rlib's user is set, exported, or you could also use a virtual or isolated environment that you may need to load or go to inside of your job script. There is such an example later in the machine learning with R. You also need to ask for resources, depending on if it is a parallel job or a serial job, if you need GPUs or not, etc. And then, of course, you need to give command to your R script or any inputs also. And then when you have done this, you submit your batch script with sbatch and then the name of the batch script. You can call it absolutely anything. It's common to use file extensions for the batch scripts like .sh or .batch, but they are not necessary. It is mainly a way of making sure they are easy to find. As you can see here on, this is on UPPMAX, but we have put .sh on all the batch scripts, which means that you can easily see them between the R scripts, which are .r. So it's useful, and it's also useful to name them in a way so you can remember what is what, but it's up to you to find a good system. So let's look at some useful commands to the batch system. The first and foremost is submit a job, and you do that with sbatch jobs and the job script. And let's try do this. I will just try submit this serial job script here. Like this. And as you can see, when you submit a batch batch script, then you get a job ID. And this job ID is what you will use to get information about the job, for instance. You can get a list of your jobs with SQ minus U and your username, or maybe more handily, SQ minus minus me. And you can see my job that I just submitted here is pending, waiting to run. And it says that it is because of reservation. So I will wait and it will run. And I can do the same thing at Cosmos. So there I would take this one here. That is also pending this time for priority because someone else has submitted a job that had higher priority. I will try also on Kebnekaise in the hope that one of them goes through quickly. We are trying here. And there I was lucky. It's already running. And here you see under the job ID, it lists the job ID of the jobs, which partition is running in. Here it's tells me it's on the Sen4 nodes, and the name of the job, which is just the job script's name, unless you name it inside of the batch script with the hashtag sbatch minus J and the name. Then the user that owns it, that's me, and then the status. And you can see the status could be pending. That means it's waiting before it can start, for instance, because other jobs have higher priority. It could be R for running, or it could be CG for completing. This job already finished. I will try submit a number of jobs like this. And then you can see that most of those are already running. So I'm lucky, not very many are running on Kebnekaise at this moment. So if you want to check more on a specific job, you would use S-control, show job, and then the job ID. And then you get a long list of information. You can see here what was the priority of the job and what is the project it was running in. What is the job state? In this case, the job just completed. Submit time, when did I submit it? When did the job start? When did it end? How long did it run? Things like this. And also which partition did it run in, which was the node, which could be good if you need to debug what errors there might have been if there was any from the node. It tells you how many CPUs, tasks, how much memory, all these things. And also which directory you submitted it from. So all quite useful. So what if you want to delete a specific job? It might be that you have submitted it, it's sitting in the queue, and you find out that you made an error that you want to fix, and you don't want this defective job to run because it might not just end immediately, or it may use resources for no reason, including from your project. So then you say S cancel and then the job ID. And if you have several jobs you want to cancel of your own, then you say scancel minus u and your username. In this case, my username is this. So that would cancel all my jobs. But you cannot cancel other people's jobs, of course. With this command here, sacct minus L minus J, there are more flags, but these are useful. And then the job ID, you get output with information about the job, such as how much memory it's using and things like this. It's a very, very wide output. So we are piping it or sending it to another program called LESS. LESS just puts out all the information inside something. So it just types the output. And then I'm giving it the flag minus capital S, which means it will be scrollable. And it's scrollable left and right with the arrow keys on your keyboard. So that's quite useful. And if you're on Kebnekaise, you can use job usage for the job ID. And by doing that, you will get a URL to a page. Then you can put this URL to a browser, and there you will get a graphical user interface that shows you information about your job, how much memory it uses, other things like this, which can be useful if you're trying to figure out why your job is not running as it should. So the main key points here: the SLURM scheduler will handle allocations to the calculation or computation nodes. The interactive session will be presented later. So this needs to be fixed. We moved around the schedule. Batch jobs runs without interaction with the user. A batch script consists of a part with SLURM parameters describing the allocation and a second part describing the actual work within the job, for instance, one or several R scripts. And one important thing to remember, since there is no interaction with the job when it's running, you need to include any possible arguments and things like that to the R script within the batch script. Okay, so let's take a look at some example codes. And I suggest that you type along and try this out. So you can see there are several tabs. And here is the script itself. It's very short, just prints hello world. And this is how it looks on LUNARC, how it looks on HPC2N, and how it looks on UPPMAX. On UPPMAX, we will use R411. And in this example, for Kebnekaise, we are using R412, and it has some prerequisites. And on LUNARC, 421 and its prerequisites. Okay, I better say something about this script itself. And the first line tells the batch system that it is running in the bash shell. Shells are something on Linux. It is different ways of writing commands, interpreting them, some scripting and things, and you can have your favorite shell that you are writing in. The default one is often bash, and that is also the only one that's completely compatible with the batch system. So because of that, just put the line there. It's not important really what it means, but okay. And then you see here, hashtag sbatch. It needs to be there. It needs to be in capital letters. That is commands to the batch system. And the batch system will go through it and see these commands. So they must be written this way. The first one is -a and then the project ID. This project that we have, it is valid for another couple of weeks, I believe. But after that, you need to change to your own project. So you would switch it to that here. And you can also see it's different at each center. So next, we need to also ask for how long the job should run with -- time equals. And then we give hours, minutes, and seconds. It can be at most 1 week. And try to ask for something that is close to what you think you will need. Not hugely too much more, because if it's a large block of time it needs, then it will take longer for the jobs to start, simply because it's waiting to find a slot that is available. But don't also ask for too little, because then the job will end before your program ended. So this is important. And then we're asking for 1 core. This is a serial job. Then we load any modules we need. In this case, R411, it's UPPMAX, there are no prerequisites. And then we are running the R script, which was hello.r. So I will try, and let's submit it on Cosmos. I just want to see it. The other one had run there. I believe it's called serial, so that was the one we just submitted, but I'm guessing we can submit it again. And you should try and submit this as well. You can either copy the text or the content here of this script for the system that you are working on, or you can just find it in the exercises/R directory. It is called serial minus and then the cluster you are working on .sh. And you submit it with sbatch and this batch script. So, and then you can try and do sq -- me and see that it ends up in this queue here. Let's do that again. Like this. Okay. And I will slowly move to the parallel code. And the main difference here is that this first here, if you're using something like for each or do parallel, then it is shared memory or whatever, so you need to run more tasks. And that means that you ask for that with minus C and the number here. And you again load the packages, and in this case you need the R packages module on UPPMAX, because that is where for each and do parallel are. On HPC2N and on LUNARC, these are included within the R. So there you can just load R and its prerequisites, and then you submit it. And let's see if I can find it. It is this one, parallel for each. So I will just submit it. And it's there, and let's see if it's running. It's in the queue, but the other one we submitted just before has finished. If you do ls, then you can see if there are new files in your directory, of course. And we are looking for something named SLURM. This one here gives the long format and also hidden files, and it is sorted by time. So that means that at the very end of the list will be the newest file. And you can see this worked here. It was, yeah, of course, this was the output from the serial job that just ran before. Therefore, parallel for each is still in the queue. Yeah, it's still waiting for priority. Okay, I will submit it here at HPC2N, since it seemed to be a good time for running jobs there. It will vary over time. Sometimes the cluster is very heavily used, and sometimes it's not. And while we leave those to run, and you should also try these, then I will continue to the R MPI. Of course, here at the tab here, if you want to look at the R script, you can see it here. So our MPI, when we are running an MPI job, we need more cores, so we are asking for that. And we are doing that, of course, on each of these centers. One thing we also do is we load an MPI module on each of the centers. And you can look into these files here and see that there are some minor differences in the naming and the versions and any prerequisites when you are loading modules, but it is minor. And you can see we are running it the same way at each center otherwise. We also need to export an environment variable to get this to run. That is because there is some problem with running our MPI otherwise. But with this environment variable, it will work. And this is the RMPI program. And we can also try run that. I should probably see what it was called. It is this one. And now I will see how it goes on UPPMAX and then try and submit it there as well. Let's look inside of it. It has the old project ID. I will change it. And now it submits. And I will also submit it at Kebnekaise. And it's now either in the queue or running everywhere. Okay. The parallel for each has also started running now at HPC2N, and you can see it has ran for 2 minutes and 26 seconds. The RMPI one has more cores, of course, and it had already ran. So let us continue. So what if you have a job that needs GPUs? Well, you should note that generally there are either no GPUs on the login nodes or you cannot access them for computations. So to use them, you need to launch an interactive job or to submit a batch job. That is to use the batch system. So on UPPMAX, Rakam's compute nodes don't have GPUs, but Snowy does. And you can submit jobs to Snowy from Rakam. And in order to do so, you need to add this to the batch script. So you have hashtag sbatch minus capital M Snowy, and then hashtag sbatch minus gres, the GPU resources, equals GPU and then the number of cards. And I believe there's an error. There's only one card on the Snowy GPUs, so it should be 1 there. HPC2N has quite a lot of different GPUs. It's a very heterogeneous resource. And the GPUs are considered a separate resource. And the regular compute nodes do not have GPUs. They are part of Kebnekaise, of course. But if you want to use them and you are applying for a project there, then you need to apply for both CPUs and GPUs in order to use both of them. And in most cases, you would want to use both of them. There is also the large mem resource for the large memory nodes, and you can apply for that as well, but only do so if you actually need them. Those are very memory heavy nodes with 3 terabytes, but we don't have very many of them. So as I said, Kebnekaise has a great many different types of GPUs, and you can see a list of them here, and you can also see how many GPU cards are per node. And that means that if you, for instance, want to use L40S, then there are some nodes that have 2 cards and some nodes that have 6 cards. That means you could ask for everything 1, 2, 3, 4, 5, 6 if you ended up on a node with 6 cards, for instance. And to access them, you need to use this in your batch script. Hashtag sbatch minus GPUs equal how many cards. And if you only put this line and nothing else, then you don't know what kind of GPU you will end up on. So if you say I want 4 GPUs and it was assigning you to the V100, then it will fail. So you should either put 1 or 2 here, or you should also include what kind of GPU you want with the hashtag SBatch minus capital C and the type, which is one of these. And when you know what type you want to run on, you can add how many GPUs you want. And that can so be from 1 and up to the maximum number on that type of node. There is more information about this in HPC2N's guide to the different parts of the batch system. And you can find that here. So let's go to LUNARC. LUNARC has NVIDIA A100 GPUs, and it also has NVIDIA A40 GPUs. But the latter ones are reserved for interactive graphics work on the on-demand system, and SLURM jobs should not be submitted to them. So we are using A100 GPUs and Cosmos, and that's also what is in the reservation. And you get to use that by adding these 2 lines to your batch script. So hashtag SBatch minus P for the partition, GPU A100, and hashtag SBatch minus minus GRES equals GPU and then how many. And that is 1 or 2, I believe. The nodes can be configured as exclusive access, and they are configured as exclusive access, and they are not shared between users. That's important because that means that no one else will run on the same node, and you will be charged for the entire node, or your project will. There are also some Intel nodes with A100 GPUs on, and you access them by adding this to it. It's more or less the same, except that it is now GPU A100i instead, and there are 1 or 2 of those. So let's look at an example batch script. So for UPPMAX, again, it is important that you put minus capital M snowy there, because otherwise it will submit it to Rackham, and Rackham doesn't have GPUs. And of course, tell it how many GPUs. So there's an example here. And for HPC2N, it is as shown above. You tell it how many cards, how many GPUs, and then what type of GPU you want. And then, of course, you load the modules you need. And this is no longer true. There are also other versions compiled for CUDA, so you can pick a newer one. You can do ML Spider and see which ones are available. But it is important to load CUDA as well, because it's a GPU job. So, and then on LUNARC, we add the 2 lines that was shown above. So the partition GPU A100 and how many GPUs. Again, load the prerequisites for R and CUDA, and R, of course. Okay, let's try and do a short exercise. But we are going to use this serial batch script up here, this one here, and you should try and change it. So pick the one from the center you are at, and then change it. So instead of running hello.r, it is running add2.r code. But pay attention, the add2.r code has arguments. So try to find out how you're doing that. If you can't figure it out, there's a solution, but you should try do it yourself first. And you can also find the solution in the exercises section on exercises/R. But I will just open the add to R code and show you, because here you can see how many arguments you need. But yes, there are examples here if you need them. And you should also try running the parallel examples further up on the page. But I am going to stop sharing my screen now, and then I'm going to give you maybe 15 minutes to do the exercises and any remaining examples up ahead that you hadn't tried on this page. And then afterwards, we will go to the parallel session. Thank you.